Hello guys, and welcome to another video on Microbit Pomodoro project. What we built so far is the Pomodoro timer that will start counting as soon as we turn on the simulator or the actual Microbit board. So if I press start the simulator button, you will see that it immediately starts counting. This is something that we would like to improve and to put ability to start, pause and reset our Pomodoro timer. Before we do any of the coding, let's first take a look at what we are going to build exactly. Finite state machine is a technique of building the applications. In that technique, you provide the states for your application and you provide some way to transition between different states. We can define states for our Microbit Pomodoro project, and we need only 3 states for now. Later, maybe we will expand on this. Init state is the first one. When you turn on the Microbit Pomodoro, you will find yourself in the init state. To transition from init to running state, we are going to use button A. So pressing on button A will start the Pomodoro timer. Pressing on button A again will lead us from running state to pause state, and pressing button A again will go back to running state. So essentially, pressing button A will do the first start of the Pomodoro timer, and then it will go back and forth between pause and running. Also, what we would like to do is to include the reset functionality to transition from pause state to init state, and we are going to use shake, which is another input from the Microbit board itself. So you literally shake your Microbit board, and if you are in the pause state, you will go back to init state. Now we are ready to implement this finite state machine in code. First, we need to have a variable that will keep track of current state, so we can call it state. And next, we are going to introduce 3 new variables: state init, state running, and state pause. This is not strictly necessary. You can keep track of the state by using a simple number, and then you can remember what was the number for each phase. But I think personally that this is much cleaner and it's easier to reason about the code. Let's create a new function and call it initialize states. This is the function that we are going to use for setting those new states onto some fixed values. We are not going to change this later on. So we have state init, we have state running, and state pause. The important thing here is that they are having the different values, so we can make a distinction between different states. And we can keep it from 0. We can just say simply state init is 0, state running is 1, and state pause is 2. Next thing that we are going to do is to introduce new inputs to our code. So we need another button press, and we want to have shake. And now let's organize this a little bit better. So let's move this out of way. We want to start with button A, then button B, and then on shake. This is how I personally like to align those blocks, and you don't necessarily have to. I will create a new function, and this one will be named start or pause, because this is what we are going to do on button A, and we need to call this function on button A press, and on shake we are going to create function reset by shake. And let's move this over here, and also let's call reset by shake in this input here. Now we can start implementing start or pause function. Let's grab if block, and we can click on this plus button to introduce more else if conditions. I don't like to have this else block, because if we ever introduce new states or change the existing ones, this else block will probably take some evaluation that we are not aware of. So let's always be very precise about what we are dealing with on this press on start or pause. So we need to compare current state, and let's find it. So if state is equal to, and let's find the state init. Okay, let me actually put it in here. And let's copy this one over. So we have state running and we have state pause. What we would like to do, and we need more space over here, so let's move everything. What we want to do here is to set state to something else. We can say set state to, and we can grab state running. And let's see, if we are in state init, we want to go to state running. If we are in state running, we want to go to state pause. And if we are in the state pause, we want to go to state running again. Now we need to provide some feedback, and let's call our save display string. And let's put here. Actually, let's call it start, so that we can distinguish between if we do it on the button press or if it was changed by the timer expiration. This one also goes to running, so we can also keep start, and here we can say pause. Now we can go here to on shake, and let's implement reset by shake. We need only one condition. We only need to inspect if we are in the pause state. So we are going to compare the current state with state pause, and let's put this into here. And we are going to, let's copy this one, save display string. So if we are in the state pause, we are going to reset our timer. When we are resetting, we want to set state to init. So we need to copy one of these, and let's say set state to state init. But what else would we like to do? We would like to do the same thing that we are doing over here. So we have on start, and we are setting a timer to work time, and we are setting is work time to true. We can also keep these two, it won't matter much, but you see that on start block and reset by shake function are going to do pretty much the same thing. So we can remove this one from here, this state init, and let's make another function that is going to be called for both on start and reset by shake. So we'll take all of this out and create a new function. Let's call it reset. And let's put all of this into a reset function. Okay, so you can see that we are already forming some nice structure with these blocks, because on the top we have utility functions, then we have our input functions, so blocks actually, button A, press B, press, shake, and on start. So now we need to call a reset in this on start block, and we want to call reset on reset by shake function. The only difference is that we are going to display string reset here, and we are not going to do that when our Pomodoro starts. Now that we implemented reset by shake and start on pause functions, we can go to display LEDs, not this one actually, but this one, forever block. This is the main function, the main block that we are using for our Pomodoro timer. And this block should not be active unless the Pomodoro is in the running state. And it's very easy to do. So we just need to provide one if block, and we can put everything inside this if block, and we need to compare if state is in the state running. Actually, if our Pomodoro is in state running. And with all these changes, let me just zoom out a little bit to see everything looks nice. And now we can actually run our Pomodoro. Let me zoom in back again. Okay. And let's run simulator and see what is going to happen. This is not what we expected, because we wanted to see Pomodoro does not start with counting immediately, but rather on press on the button. So we can inspect this behavior with debugger and to try to figure out what is going wrong. I will stop this now, and I can run debugger with pressing on this button, toggle debug mode, and it will give me all those gray circles next to each, you can say, element, and we can simply click in this one to see, actually not on this one, but let's go straight to forever block, and let's see why it goes into here. If we click on this button, it will stop on this breakpoint that we made here. And now we can inspect what is happening. So state is 0, but state running, state init, and state pause are all 0. If you remember, we wanted to make them distinct by providing different values, 0, 1, and 2. The problem is that we didn't call this initialize states function anywhere. Let's stop debugger by clicking on this button again. Let's go to functions and call initialize states, and let's see, do we need to put it in a reset function, or is it enough to be run just once? Because we are never going to change these values, it's enough to call this function just once, and it will keep these values throughout the whole application. Now if we go back to debug mode and we point here, we put a breakpoint here and then run the application, you will see that state init is 0, state running is 1, state pause is 2. And the current state is 0, which is state init. So now we can just click on this, but it will always go to this breakpoint, so we can remove it, or we can simply get out of the debug mode and run it in normal mode. And now, if we press on button A, it will start the Pomodoro timer. And let's see, it should, yes. So now it's blinking. And now if you press on button B, you can see the current time, 24:49. Let's give it a second and let's click again. So it will be 24:41. Nice. Now let's click on button A again, and now it will go to pause. And now let's click on button B. The time now is 24:32, and we hope to see the same time when you click button B again. And it is the same time, 24:32, so we can conclude that this is working now properly. There is one improvement that we can make to our pause state. Now, if you look at it when we start our Pomodoro timer, init state and pause state look pretty much the same. They don't indicate any difference between them. And to do this, we can take another forever block and we can inspect. Let's take if block, and then we want to see if we are in the state pause, and we can simply move this down. And if we are in the state pause, then why is this not okay? Now it's showing fine, and we can simply show string p. The reason I'm doing it this way is we don't need to call save display string because we are not going to display LEDs, so nothing will be clashing with this function show string. And let's test it out. So now we can start the simulator. We can start the Pomodoro timer. And as soon as we press pause, it should print out pause, and then it should display this string. So we click on button A, pause, and now we have P to indicate that it is pause. If we click on button B, it should display the time that is left. So it's 24:49, and as in the last time that we run it, it will keep this time the same. So we know that this should work. And the only thing that is left to do is to test the shake functionality. To simulate the shake, you just need to quickly move your mouse left and right, and it will indicate to this simulator that you are shaking the board itself. So if we do this, it will shake, and then it will print out reset, and it will go back to init state. As you can see, init state is indicated by not providing anything on the LEDs, but still we can press button B and it should display 25:00, which is the left time for the work phase. That's all for this video. I hope that you enjoyed it. Thank you for watching and see you in the next one. Bye bye.